Okay, Pre-Cal 10, here we go. Everybody's favorite, applications and modeling, which is just fancy words for word problems, real life scenarios that you always ask for, but then you never actually want to think about. So here we go. Using the graph provided, find an equation to determine the relationship between Celsius and Fahrenheit. So what you can see here is you can see the y-axis is Fahrenheit and the x-axis is Celsius. And we have some comparisons here. When we are 0 degrees Celsius, we are 32 degrees Fahrenheit. And when we are 100 degrees Celsius, we are 212 degrees Fahrenheit. Basically, what's the slope of this line? We need to know that. And we have 2 points. So, y2, let's say 212 minus y1, which is 32, over 100 minus 0. Metric system is so much better. We end up with 180 over 100, which simplifies to 18 over 10, which simplifies to 9 over 5. So the slope of the line is 9 over 5. Now just think y equals mx plus b, right? Well, what's my b value? My b value is staring me in the face right here, 32. So we get y equals 9 over 5x plus 32. But since we're dealing with real life scenarios, we sub in for our y and our x for different variables, because in this case, what is y? Y is my Fahrenheit. So Fahrenheit is equal to 9 over 5 times Celsius plus 32 degrees. And would you look at that? You just determined the equation for converting degrees Celsius into Fahrenheit. And if you're ever thinking, you hear Fahrenheit, and you're like, well, what is that? Or you hear Celsius and you want to know Fahrenheit, 9 over 5 is almost 2. So basically double Celsius and add 32, and that's how hot it is in Fahrenheit. Okay? There's an equation for Fahrenheit to Celsius, but we'd have to run that a different way. But there's an equation that solves for Fahrenheit. So here we got a popcorn problem. There's going to be multiple points to fill in, so we're going to do little bits at a time. So let's start with what we got. It costs $490 to make 150 bags of popcorn and $610 to make 350 bags. So on the bottom here, we got bags of popcorn, and on the top we have money. So let's plot these points. So we have 490, 150. So watch the scale of your graph, but there's 150. We got to go up to 450, 460, 470. So we are just about here. So this is not going to be perfect on my graph. There's a much nicer graph in the notes provided, but let's just use this one, okay? And then when we are at 610, 350, so 350 is right here. We are at 610, so we're going to be up quite a bit higher. We are right about here. So there's our 2 points. Now, if we had a perfect ruler, you draw a line through these points, and we have an intersection. So find the cost equation. Well, the cost equation, we're going to need the slope, because the cost equation is going to be our slope-intercept again, right? So we have y2 minus y1. So what are our points? Well, we have 350, 610, and we have 150, 490. So for our slope, which is going to be dollars per popcorn, right, we have 610 minus 490 over 350 minus 150. So what does that give us? That gives us 120 over 200, which simplifies to 12 over 20, which simplifies to 6 over 10, which gives us 0.60, because we are talking dollars per bag of popcorn. So it's 60 cents per bag of popcorn. So we have the slope, and then all we need is, well, what's my y-intercept? And can't really see it perfectly on my graph, what we could always do is we could use our slope-intercept equation because we have this equals 0.60x plus b, and then just pick any point. So I'll just use the first one. So 490 equals 0.60 times 150 plus b. And if we work this out, we end up solving for b, and we get that b is equal to 400. So that way we get this equation. Y equals, and you can plug that into your calculator, right? Do the 0.6 times 150 and then subtract from both sides. But y equals 0.60x plus 400. And obviously, again, we want to put this into appropriate variables. So the cost C is equal to 0.60. So that's dollars. We don't put that in our equation, but remember that that's dollars, right? Or in this case, cents, 60 cents, times the number of bags. So let's use the letter B. And then plus 400. So that is our cost equation. What this plus 400 means here is it means that that's sort of my setup cost, right? It's going to cost me $400 regardless of how many bags I produce. And then every bag I produce starts to cost me a little bit more money. So find the fixed cost. Well, the fixed cost, if this was our equation, what's my fixed cost? Well, that's exactly what I just talked about. That number there is not going to change regardless to what you do. It's your y-intercept, so the fixed cost is $400. And then find the cost for 250 bags. So this is where we have an equation. Cost equals 0.60 times b plus 400, and in this case it's saying it's giving you a bag value, so we just plug in for our bags, and it's asking for cost, right? So cost is equal to 0.60 times 250 plus 400, which is going to give you, plug that in through your calculator, and you get that the cost is equal to $550. So we're now using our equation to solve for particular sets of information. So now the last one is how many bags can be made for 724. So that would be my cost, right? So in this case, I have 724 equals 60 cents per bag plus 400. And I want to solve for b. So this is pretty simple algebra. Subtract 400, subtract 400, and you get 324 is equal to 0.60b, and then divide by the 0.60, and you get your number of bags. And in this case, b equals 540 bags. So once you have the equation, you can do quite a bit with it, and you can figure out certain information depending on other information you have and or need. So it can be super duper handy. So let's do one more here. So a family has a medical plan that pays 70% of all prescribed costs, less than a $200 deductible each year. So write a function that models the family's responsibility for prescription costs. So this sounds kind of hard, and it is kind of hard, right? Because we got to look at a whole bunch of different things here. But first, let's assign some variables. We're going to say, okay, they're going to get a refund, and they are going to have to pay for a certain amount. So let's just say that R will be the refund. Okay, and C will be their cost. So let's figure out what this is going to look like, right? Because they get a discount on their cost. So if we think about it, the plan is 70%, which is a slope, which is 0.70, which is 70 over 100. So there's our slope right there. And then when the cost is $0, they still have to pay a $200 deductible. So that means your y-intercept, when you're at 0, you're still paying, so negative 200. So this isn't easy information to come up with, but we got to work our way through. So that means we can write an equation. We can write an equation, y equals 0.70x minus 200, but let's put our variables in here properly. The amount of refund is equal to 70% the cost minus the deductible. So let's see this in action then. First of all, determine the amount the medical plan will pay at $1,250 prescription costs. So how much refund are we going to get basically, right? How much will the medical plan pay if the cost is $1,250? So 70% of $1,250, but then we do need to pay our deductible, right? So we run that through, crunch those numbers, and you will end up with an R equals to $675. So that means on a $675 refund from a cost of $1,250. And I use those numbers like that because those will come in handy. You'll see when we have to graph this thing. Okay, so let's keep going. Same question. I've just split it into multiple pages. So now determine the amount spent on prescription purchases if the amount paid was $1,250. So in this case, the refund was $1,250, and we want to know the cost. So we're working backwards, right? So now this time $1,250 equals 0.70 times the cost minus 200. So we'll add 200 to both sides, and we get 1,450 equals 0.70 times C. Divide by our 0.70. 0.7 is fine. We're just using 0.70 because we're talking 70%. And we end up getting $2,071.43. So in this case, R was $1,250 and C was $2,071.43. So let's just look at the last bit. How can we graph this? So be aware of your scale here. And what we're going to do is we're going to label this a little bit. We're going to say, okay, this is my cost here. This is my refund here. Okay, and if you look at the scale, 500 is, we'll change the color. 500 is here, 1,000, 1,500. Okay. And if you look at the scale on the other axis, 1,000, so 255, 750. Break down the scale here halfway. So that there would be 500. Okay. So we're just going to try and ballpark this graph, but see how we have the R and the C, right? And we had two values. We had 675 for 1250. So we had R was 675. So we had 1250 comma 675. And then from this one we had R was 1250. And C was 2071.43. So R was 1250 this time. So this way, and C was 2071.43. So what we have is we have 2 points, and we'll just kind of ballpark these. So when X is 1250, Y is 675. So here's 1,000, there's 1,500, so 1250 is right here. 675, so that's 500, which would make this, so let's just throw it right about 1250 there. And then when we're just past 2,000, we're up at 1250, so we have a point at about there. So you can see that your graph would look something like this. It would take off the grid. And what you have on here, this was our C value, right? This was our the relationship between our prescription cost and the refund we got. And this was our B value, which was our prescription cost and the refund we got. So obviously you can see that the lower the cost, the less the refund, the higher the cost, the higher the refund, but that just makes sense because you're getting a percentage of your cost. Don't stress out too much about this. This is a pretty complicated version, but you just want to make sure you can pull the necessary information out of a word problem. So try the practice problems here for section 3.4. There's about 6 of them. remember that when you're writing the equation of a linear application, if you have something in this form, you eventually want to move it to something in a form with variables that are pertinent to your discussion, right? So this could be value is 40% of, the goods. So use variables that help your questions make sense. We'll talk a lot about this in class, so don't hesitate to ask or comment if you want a short video with particular questions. Okay, great work.